So today we're going to look at a second way to solve percent problems, and that's the percent equation. And when we're working with percents within this equation, we're going to put them in their decimal form. So just a brief reminder of how we can change a percent to a decimal and a decimal to a percent. So if we have a percent and we want to change it to a decimal, we need to divide it by 100, which means that the decimal point will move left 2 places. So for example, let's say I have 56%. That would be equivalent to 56 out of 100. And we know that division is a fraction, so we could also think about this as 56 divided by 100, which is 56 hundredths. So we don't need to write this step. We can just use the pattern that to go from a percent to a decimal, we divide by 100, move the decimal 2 places left. This is also the case if we have a percent that is greater than 100. We still follow the rule, dividing by 100. So 120% would be equal to 1.20. Even if we have a percent that is less than 1, so let's say I have 0.4%, I still follow the same rule, dividing by 100, move the decimal 2 places to the left. So that would be equivalent to 4 thousandths. And if we have a decimal and we want to write it as a percent, we do the opposite. We multiply by 100 and we move the decimal 2 places to the right. So for example, let's say we have 12 hundredths. Well, as a fraction, that would be equivalent to 12 hundredths, which means as a percent, 12%. So we take the decimal, we move it 2 places to the right, multiplying by 100 to get the percent. So for example, let's say I had the decimal 1 and 35 hundredths. If I multiply that by 100, I get 135%. Let's say I have a decimal like 3 thousandths. Multiply that by 100, that would be 0.3%. So our benchmarks to remember here are that 100% is equal to 1. 200% is equal to 2. 1% is 1/100th. So those are good benchmarks to remember as you're going back and forth between decimals and percents. So the percent equation is that if we multiply a percent by our whole amount, we get the part or the percent that we're looking for. The thing we need to remember with the percent equation is that the percentage needs to be written as a fraction or a decimal for this to work. So for example, we know that 30% of 100 is equal to 30. And so if we write that mathematically, 30% is 31 hundredths, or as a decimal, 0.3. 0.3 times 100 equals 30, which we can double check on the calculator is true. So the fraction or decimal form of the percent times the whole equals the part. And this equation can work to solve any of the 3 missing pieces, either the percent, the whole, or the part. As we're working with percents, you'll notice there are a lot of different methods for solving percent problems. And you may already have known another method. You might start noticing patterns that can make your work more efficient. That's fine. But we also need to have some strategies for those times where we're not sure what to do. So for the purposes of today, I want you to try setting up the percent equation so you know how to work with this strategy. All right, so let's look at 3 examples of how to use the percent equation to find either the percent, the whole, or the part. Now, when we worked with proportions, we needed to identify which pieces were which and put them into the proportion. But when we're working with equations, one of the nice things is we can simply take a sentence like this and translate it into an equation. So for example, 20%, if I write that as a decimal, is 0.20, which is equivalent to 0.2. Of means multiply. So 2 tenths of 150, so that's our whole, and we want to know that's equal to what number? So anything we don't know, we let an X stand for. So 20% is the percent, of 150 is the total amount, and the part is what we're looking for. But again, if I just directly translate that sentence, I actually get the equation. So now X is already by itself on that side of the equation, so all I have to do is evaluate that side, which would be 30. So 20% of 150 is 30. Is that a reasonable answer? Yes, because we're finding 20%, so the answer should be smaller than 150. And definitely less than half, which would be 75. All right, let's take a look at the second example. 45 is what percent of 60? So I can see that the percent is what I'm missing here. Let's try translating this sentence. 45 is, or equals, some percent, we don't know, so let's let a variable stand in for that, of 60 means times 60. So 45 is our part, and that equals some percent times 60, the whole. Now I'm going to solve my equation, dividing both sides by 60. When I do that, I get X equals 75 hundredths. And here's where we have to do one more step. So if you're asked for the percent and you're using the equation, the final step is that you must take the decimal value and write it as a percent. So if we take 75 hundredths and we want to write it as a percent, we need to multiply by 100, which is 75%. So 45 is 75% of 60, which makes sense because it's smaller than 60, but greater than half, which would be 30. And finally, 35% of what number is 35? So 35%, I can write as a decimal, 0.35, of means multiply, some number, so 35% of some whole is equals the part, 35. Now I'm going to solve my equation by dividing both sides by 35 hundredths. X equals 100. So 35% of 100 is 35, which makes sense. So by putting that answer back into the statement, we make sure that what we have is a reasonable answer to the question. All right, let's look at a few more examples. And just a reminder that these are good things to have in your notes to look back on. All right, so let's translate this sentence. 0.8% of 150 is what number? So I'm looking for 0.8% out of 150. So I've got the percent and the whole, and I'm looking for the part. So remember, I need to write this as a decimal. So I need to divide it by 100. Of means multiply, is equals a mystery number. So let's evaluate this side of the equation. So X equals 1.2. So 0.8% of 150 is 1.2. And that's a reasonable answer because if we think about 1%, would be 1.5 if we divide 150 by 100. So we would expect that 0.8% would be less than 1.5. So 1.2 is a reasonable answer for that question. All right, second question. 29 is what percent of 20? So 29 is equals some missing percent of times 20. So what we're missing here is the percent, but we know that the part is 29, and we know that the whole is 20. So it would make sense here to have a percent that's greater than 100 because the part is greater than the original whole. So our answer should be greater than 100%. So let's solve for x by dividing both sides by 20. X equals 1.45. So that means if I multiply 20 by 1.45, I would get 29. But we need to write that as a percent. So if I multiply by 100, that's 145%. So 29 is 145% of 20, which again is a reasonable answer because it's greater, the part is greater than our original whole. And finally, 0.5% of what number is 12? So 0.5% written as a decimal is 5 thousandths of something, we don't know, is equals 12. So I'm going to solve for x by dividing both sides by 5 thousandths. Remember that dividing by a decimal actually makes your solution bigger than what you started with. So x equals 2,400. So that's the whole we're looking for. So basically what we're saying is that 12 is 0.5% of 2,400. And that makes sense because again, if we just calculate maybe 1% here, then that would be 24. So the fact that 12 is less than 24 means it makes sense that it's less than 1%. We're going to have real life situations where we don't always have the sentence written out for us. So now we're going to look at two examples of how to take a question with a context and write it in a sentence. Let's say that we had a fundraising goal of 2,000 leva and 140% of the goal was raised. How much money was raised from the fundraiser? So we know the percent is 140%. So more than the goal was raised, which is always a good thing when you have a fundraiser. So we know 140% of some whole is the part. So the question is the 2,000 leva the whole or the part? So it says the fundraising goal was 2,000 and 140% of the goal was raised. So that means that this 2,000 is the whole. And what we're looking for is the result. So we want to know how much is 140% of 2,000, and that's our missing piece. So 1.40 times 2,000 equals our missing part. Then when I multiply, I get 2,800. So that means 2,800 leva were raised, which is more than the original goal of 2,000. Here's another question. The fundraiser brought in 2,000 leva. This was 80% of the goal. What was the goal? So we know the percent. So we know that 80% of whatever the total was gave us the part. So in this case, the whole would be the goal, and the part would be the money we actually raised. Well, it says that the fundraiser brought in 2,000 leva, and that this is 80% of some goal. So what we don't know is what the original goal was. So that's the whole. We do know, though, that when we find 80% of x, the result was 2,000 leva. So if I write that in an equation, I get 0.8 times x equals 2,000. And I'm going to divide both sides by 8/10. And I get $2,500 or leva. So the original fundraising goal was 2,500 leva. We raised 2,000, which is not quite all of the goal, just part of it. So when you have a word problem, the goal is to translate it into a sentence and then an equation.